the functions we are dealing with now are called reciprocal functions. What do you think a reciprocal function looks like, based on the name? Upside down, numerator, denominator is kind of switched. That's pretty right, because what makes a reciprocal function is that in our equation, the x is in the denominator. So it is. It's flipped upside down. That is your parent equation right there. That is an inverse variation, okay, which is what you were doing in 9.1. Okay, direct variations, the x will be on top. Inverse variations, the x is in the denominator. Now, for that parent function, y equals 1 over x, what can x not equal? There's one value that it will never be. 0. Why? Why? Because what can equal 0? Uh-huh.
It's a number.
Huh? It's a real number. Okay, why can x not be 0? Why is it particularly it can't be 0? Can't have 0 in the denominator. No, no straight lines. Okay, so it can't be 0 in the denominator. And this is what your graph looks like. That's your parent graph. There are actually two parts. Here's a part, and here's a part. All right, so all these graphs that you're going to do have two parts. Got it? Remember that for your homework. Here's the general form, with h and k. All right, we'll deal with h and k tomorrow. Today we're dealing with this a. But the reason I'm showing you this is just so you know, for domain, it's all real numbers, except h and x cannot equal each other. If they did, you'd have the same number subtracted from itself, which would equal 0, and that can't happen. So whatever, you can figure out the domain for all the equations just by using this. X can't equal h. All right, that's the basic overview of reciprocal functions. Let's see. So we're going to start by graphing an inverse variation, which is a reciprocal function. And the one that we are going to graph is y equals 6 over x. All right, so the difference between the parent function and this one is that the 1 is turned into a 6. When you graph these, you need to make sure and graph positive and negative values of x. So it says make a table of values that includes positive and negative values of x. I'm going to choose numbers that I can make work easily with when I divide 6. So I'm going to go -6, -3, -2, and -1. Can't use 0. 1, 2, 3, 6, and I'm not even going to use that last box. Yay. So what is 6 divided by -6? -1. All right. 6 divided by -3.
-2.
6 divided by -2. -3. 6 divided by -1. -6. Now, 6 divided by 1. 6 divided by 2. 6 divided by 3 is 2. 6 divided by 6 is 1. On your homework, they tell you to show a table of values. So you can do it like we did and find them on your own, or you can use your calculator to help you. Though that's not my favorite, but it is allowed. All right, so your calculator can show you a table, and then you need to write it down. Make sure you have positive and negative values for x. Okay, graph those points, but when you connect them, you're going to connect the points to the left of x equals 0. So it's to the left of here. So over here connect points and over here connect points. You'll have two parts of the graph. Each part of the graph is called a branch. Okay, that way you can say like the positive branch or the left branch or right branch. That way you have something to refer to. So go ahead and graph those 8 points and we'll make our graph. Make it actually look like it's supposed to.
Did you pick any numbers and made that work?
Yeah, anything besides 0, you can plug in for x to make it work. I just picked ones where it wouldn't be like a weird fraction. Like if you divided 6 by 5, it's 6 over 5. So I just picked numbers that kind of would divide pretty. Everybody get your graph to look like that? Okay, so now let's talk about the asymptotes that are part of this graph. Remember, asymptotes are the lines that the graph gets really, really close to but never touches. I'm going to make blue here so you can see. So it gets really, really close to this line but never touches it. And this one and never touches it. You see that? So to infinity and beyond, get really, really close, but it'll never actually touch it. So the x-axis, this one here, is what kind of asymptote? An HA or a VA?
Horizontal.
Horizontal. What is the equation for that line?
What was that?
No. Any guesses? It's y equals 0. The x-axis is y equals 0. So what does that mean the y-axis is? X equals 0. And it is a vertical asymptote. Okay. The branches of the parent function are in which quadrants? Do you remember which quadrants are which? Which one's 1? Top right. And then where do we go from there? 2, 3, 4. So I'm going to go ahead and label those just so we have them. So here's 1, 2, 3, and 4.
So if S, let's up stuff on like the input number, rounding numerals, right?
I will understand both. I don't think you have to write it. Okay. So the branches of your parent function, which is this one up here, You see those are in quadrant 1 and 3. So that's what most of your equations are going to be, 1 and 3. Like this one, they're in quadrant 1 and quadrant 3. If we change the a value, which we did for this one, that is called a stretch. Okay, so a values, same as usual, cause a stretch. So stretches of the parent function have the form y equals a over x. So instead of a 1, there's something there. If the a is bigger than 0, then they stay in quadrants 1 and 3. Okay, so a positive number stays in 1 and 3. Their reflections, which are caused by a negative number in the top, so like if it was a -6 or down below it'll be a -4, those are in opposite quadrants. They are in quadrants 2 and 4. 4. Do we need a side topic on Roman numerals? I like it. Okay. So let's graph one of these reflections. Since it's a -4, you know it's going to be in 2 and 4, the quadrants. So that at least gives you a little hint of where the branch is, what it's supposed to look like. So let's make a table. Yes. For x and y. What numbers would be easy to plug in?
1, 2, 4.
1, 2, and 4. But we also need the negatives.
-1, -2,
Yeah. If you want your graph to be more developed, then you could do -8 and 8 also. No? Okay. All right, if you plug in -4, what's -4 divided by -4? 1, -4 divided by -2. -4 divided by -1. 4, and then what are the next ones going to be?
Just kidding, there's
-4, -2, -1. Okay, let's go ahead and graph those. Remember, they make curved branches, which is why sometimes it's better to... You graphing back there? Mm-hmm. Are you? Sometimes it's better to get a few more points, so that way you're more confident about the shape of your graph. But if you're all right, then you're all right. So the last part of this for today is that you have to describe the properties of the graph. So it's the last chunk of problems out of the 9. So here are kind of your outline of what you need to talk about. So this is stretched because that is not a 1 right there. So we would say stretch by a factor of, you go with the positive version of whatever that says, 4. So stretch by 4. Was it reflected from the parent function? Yes, so we'll say reflected. If you want to say over x-axis, you can, but you don't have to. Okay, what's the horizontal asymptote? You can use what we did up above. Yes. Horizontal asymptote is y equals 0. What's the vertical asymptote? X equals 0. So you need to have all those things on your paper as well. So I made you the graph paper that's kind of set up for this assignment if you want to use that. If there's not enough room, you can do work on the back. Just make sure I can see what it is, or do it on a piece like notebook paper and just staple it together. All right. But make sure you have all the answers and stuff on the front page. All right.